Hi everyone, welcome to Knowledge Center. Today we shall have a discussion regarding the clamper circuit. So clamper circuit is nothing but it's a shifting of a AC input signal to either a positive or a negative side. So at the output of this clamper circuit we get the complete DC component. Means the waveform will be shifted either towards the positive side or a negative side. Okay, so I'll just show you the waveform. After that let us see the definition of a clamper. If the input signal is sinusoidal waveform like this AC, after applying this input to a clamper circuit, the output we may get it like this. So this is complete, this waveform is shifted to the positive side. Say this is of 5 volt and this is of minus 5 volt. The peak to peak value will be 5 plus 5, 10 volt. So this complete 5 to minus 5 sine wave will be shifted towards the positive side. This is one option we have. If we shift towards the positive side, then we call this kind of a clamper as a positive clamper. If the same signal is shifted towards the negative side, even this is possible. You can do it like this, below the 0. Okay, if we shift towards the negative side, then we name it as a negative clamper. Means now we can define this circuit as a clamper circuit is nothing but it is going to shift this input waveform towards the positive or to the negative portion. So it is just giving a DC output in the output signal. Okay, it is just providing a DC component in the output signal. So as it is providing a DC component, we can also name this as a DC restorer or DC installer. It is installing the DC component at the output signal, and also we can say it is restoring this DC component into the output signal. So the clamper can also be named as a DC restorer or a DC installer. Now as I told you, it can be shifted towards the positive or a negative. If the signal is shifted towards the positive, we name it as a positive clamper. If it is shifted towards the negative, we name it as a negative clamper. So here we got the classification of a clamper. There are two types of clampers, positive and negative clamper. So before looking into the circuit, I'll tell you one more thing here which you need to concentrate on. See, in clamper what happens, the peak to peak value will remain same. Here I have plus 5, minus 5. So here 5 volt, here 5 volt. The peak to peak value is 10 volt. If I apply a positive clamper, this complete signal will be shifted towards the positive side. And here this will be now, it starts from 0 and it will be up to 10 volt. Okay, this is 5 volt, this is 5 volt. The amplitude is not going to be changed. Only the directions are changed. Okay, it is shifted, right? So amplitude or peak to peak value will remain same in the output. You can compare this with a clipper. In clipper, the amplitude is going to change. But here, it's not going to change. Only the shifting will be done. Right? So, now let's see what are the application. Before going into the design, before understanding the design of this, let's see why we are going to use and where we are going to use it. See, one example we can consider here. These clamper circuits are used especially in a television receiver, TV receiver. In TV receiver what happens? We get the DC component signal also. But in TV receiver we have a capacitor coupled amplifier. Capacitor coupled amplifier is available in the TV receiver side. So when it receives the signal, the capacitor will block the DC component. Right? It blocks the DC component. But generally, to have a black and white reference lines on a television, we need that DC component. So after this amplifier, the DC component is blocked because of capacitor. But I want to restore that DC component into the signal. So there I use this clamper to restore the DC component. Okay. So that is one example or application where we use this clamper circuit. Now let's move on to the design parameter of it. There let us understand the positive and negative clampers in detail. And watch this video till the end so that I am going to give you the short tricks of solving these kind of circuits. Means I'll tell you how to get the waveforms by just looking into the circuit. Okay, so let's move on to the design parameter. The clamper circuits are generally going to have 3 parameters in it, 3 components in it, that is R, C and D. In short, I have told it as an RC and D. Generally, it will be resistance, capacitance, and a diode. You will have a resistor, capacitor, and a diode. Let me draw the circuit. There will be a capacitor, a diode connected in this fashion, and a resistor connected across it. So this will be the component we used for clamper. Let's say this is an input signal. We are giving an input and we get output across this resistance R. So this is C, this is D. Assume that this is an ideal diode. And here you need to make two considerations. This is an ideal diode. I will consider it as an ideal diode. And the values of R and C are so selected such that the time constant is very large. The time constant is very large. Okay. So to have a large time constant, you should have very large values of R and C. Now if I give some input signal, let's see how it's going to operate. Let me explain you the operation of this. So if I have a sine waveform, input sine waveform. Let's see some mathematical expression. After that we'll look into the graph picture. So during positive cycle, what's going to happen to the diode? During positive cycle, this diode will conduct because we have anode here. So this will conduct and this capacitor will get, the current will flow like this. The current is going to flow like this. We won't get any current here because I assumed that this is a ideal diode. Okay. So there will be no output during positive cycle. Current will flowing only in this loop, and at that time this capacitor will get charged in this direction. So let's write the polarities. Okay. So this capacitor will get charged to what level? Up to the maximum value. So what is the maximum value? Say Vm. So this capacitor will get charged to Vm during positive cycle. And now during negative cycle, this diode is going to be open because this will be in off condition during negative cycle. So at that time, the current will not flow like this. The path of current will be through the resistor. So we get the current like this. The circuit will be closed in this fashion. So now the output will be obtained at the resistance, but have one point in your mind. We considered that the time constant is very high. The values what we selected over there are very large. So even there is no flow of current in the negative cycle here, the capacitor will hold that Vm within as it is. So there is a Vm voltage and even this negative Vm, maximum voltage, negative input. This is also Vm. So Vm plus Vm, that complete output will be coming at the output side. Right. So whatever the input I am giving, this including this, we get the output. So mathematically let us write what will be the expression. So I can apply the KVL here. Right. So minus to plus, it is V in, plus to minus is minus Vm, or you can say capacitor voltage, whatever the voltage it is. This plus to minus V out is equal to 0. This will be the expression using KVL. Now what we want, I want an expression for V out. Therefore output voltage, I will just take it to the RHS side, it will become positive. So V out is equal to V in minus Vc. This is an expression. This is an expression for a clamper circuit. This holds good for the negative clamper circuit. Okay. So here what is Vc? Vc is nothing but maximum. It is charged up to maximum value of the voltage. So I can write that V out is equal to V in minus Vm. Now to understand what will be the output, we shall apply some different input conditions. Means we have 0. If input is voltage is 0, what would be the output? And let's see, if input is Vm, what would be the output? If input is minus Vm, what would be the output? So let's write that part here. If input is 0, we get V out as, what is V in minus Vm? V in is 0, so we get minus Vm. Now if V in is 0 is over, now I will take maximum in positive side, that is Vm. If V in is equal to positive Vm, then the output voltage can be written as, in place of V in you put Vm. Vm minus Vm, it will be 0. If input voltage is negative Vm, means at the negative cycle, minus Vm, then minus Vm, we get minus 2 Vm. This is the output. So this is the output what we are going to obtain for this circuit. For this circuit, there was a diode like this. So now we can plot this. I hope this is clear for you. This is an output equation. Based on that, I have written this output here. Now, if I plot the output, let me plot the output here. For all the conditions of the input, from 0 to maximum Vm and minus Vm, we have only negative waveform here. So, it's nothing but the output will be shifted from, okay, if input is 0, what is output? It is minus Vm. So, if input is 0, output is, say this is minus Vm. Output starts from this point. If input is Vm, output is 0. So, if input is maximum, output is 0. So, it will be moving like this and it is output is 0. Now, what happens? If input is minus Vm, output is minus 2 times of it. So, you can plot it like this. So, this is minus 2 Vm, this is minus Vm, this is 0. So, complete this input is just shifted towards the negative side. So, this is called negative clipper. Right? So, I hope this is clear for you. If these concepts are clear, just press the like button there. Okay? Don't forget it. And also share this among your friends. Put a comment in the comment box so that it will motivate us to upload more videos. Okay? So now, let's understand the positive cycle or a positive clamper. This is a negative clamper. It is shifting towards the negative. If it is a positive, only one thing will change in positive clamper, that is the position of diode. It will be reversed. See, one hint I will give here. If this negative terminal is towards the ground, then that is a negative clamper. If the positive terminal is towards the ground, positive means the anode. If the anode is towards the ground, then that will be a positive clamper. Okay, you can remember it in that fashion also. So now let us write some expression. I will have the same input signal. Now let's see what will be the expression here. First let us write the condition, that is mathematical expression. See what happens here. First let us understand during negative cycle what's going to happen. The diode will conduct during negative, not during positive. So I will start with the negative cycle there. During negative cycle, the polarities will change like this. Now this will be negative, this will be positive. Okay. So during negative cycle, what's going to happen? Let's see that. During negative cycle, diode will conduct, and during that conduction of a diode, the capacitor will get charged up. So the capacitor will be charged to the maximum value. Okay. So what you can say, the capacitor will charge like this, minus to plus Vn, and current will flow through this only. There will be no output. But once we get the positive cycle, the current will start, whatever the storage voltage is there, that will start discharging over there. It will start discharging. Okay. So during positive cycle, during negative cycle it is charged in this fashion. During positive cycle, this is going to become plus and this is going to become minus, and it will start discharging through the resistor R. So now let's write the expression. Therefore, the output voltage can be given as plus to minus to plus, it's a plus V in, minus to plus Vc. Then here plus to minus is minus V out equal to 0. Therefore, V out is equal to V in plus Vc, where Vc is Vm, so I'll write it as Vm. Vc means that it is charged to the maximum value of the input voltage, so I'm just mentioning it as Vm. Okay. So compare it with the negative clamper. There we had a minus, here I am having positive. So in short we can say the output voltage of clamper circuit can be given as V in plus or minus Vc. This is in general. Plus for positive clamper, minus for negative clamper. That is what you need to remember. And one more thing, if the positive terminal is towards the ground, then that is positive clamper. If it is reversed, negative terminal is towards the ground, then that is a negative clamper. So let's see the output equations. If this is the condition, what will be the output? If input is 0, we get positive Vm, we get positive Vm. If input is Vm, then we get 2 times Vm plus Vm, we get 2 Vm. So here we get 2 Vm. If input is minus Vm, then we get 0. We are going to get 0. So it's nothing but what happens here. If input is 0, we have Vm. So the output can be represented like this here. I will show that output fashion. 0. Let's start with the origin here. If input is 0, maximum output is maximum. So at this 0 input, output will be maximum, say somewhere here, Vm. Okay. And if input is Vm, if input is maximum, then output will be double of it. Output will be twice of it. So we get like this. Okay, it will be 2 times of it. So somewhere say 2 Vm. And if input is negative, minus Vm, then it is going to be 0. So if input is minus Vm, it has to reach 0. And this is how the signal will flow. It will flow. So the complete signal of input has been shifted to the positive side. That is why it is called positive clamper. I hope this concept is very clear for you. But in exam, you get questions, you won't get the questions like this. One more source will be added in this branch. Now let's understand those kind of circuits. Let's see how to solve those kind of circuits. This is the basic formula. I hope it is very clear for you. The basic equation is this: plus for positive, minus for negative clamper. Okay. Now let's change this. Means here exactly what happening here. I don't have any DC source here. So what we have done, the shifting is exactly from the 0. So from 0 it is shifting to the positive side. If it is negative, from 0 it will be shifting to the negative side. If I had some circuit, some element in this branch, then what happens? Let's see that. So that is what the practical questions problems asked in the exam. So let us consider one simple waveform, and without I'll tell you how to solve those kind of problems. So this is capacitor, and we have, let us assume that this is the reference voltage I have. So this is 4 volt, and we have minus to plus. This is positive, this is negative. So I have 4 volt here. This is capacitor. Let's see let's say the input signal is somewhat like this. This is the input signal, and the magnitude of this is 5 volt, and this is minus 5 volt. Just they give the circuit like this and ask you to represent the output of it. So what would be the output of this circuit? First of all, you need to identify what is the output. First I will tell you how to solve it using mathematical expressions. After that, without mathematical equations, you can just draw the output. Even that short trick will be explained for you. So for that, you need to watch till the end. So here, let's solve the problem now. During positive cycle, let's say this is time t1, this is time t2. During positive cycle, this diode will not conduct. During positive cycle, this diode will not conduct, in the sense this is in the off mode. So the capacitor will not be charged. Let's start with the negative. So I will take up with this cycle. If T1 and T2, during negative cycle, this diode will conduct, and it will act as a short circuit, so that the current will flow in this fashion, and the capacitor will get charged up. Now you need to identify what is the capacitor voltage. Whether it is going to charge up to maximum voltage, that is fine, or not. So for that, let us apply the KVL. So during this negative cycle, let's see what's going to happen. See, during negative cycle, the capacitor will charge like this. This will be minus, this will be plus, and minus plus, and this is the short circuit, and the current will flow like this now. Current will flow through like this. And we have plus minus 4 volt source. So by applying KVL, we can get an expression. Plus to minus, so minus V in, minus to plus is plus Vc, and plus to minus is minus 4 volt equal to 0. Where I can say, therefore Vc is equal to, if I take it to the RHS side, this is going to be V in plus V in and a plus 4. So what is the input voltage we have? 5. The maximum input voltage is 5. So 5 plus 4, we get 9 volt. So the charge capacitor voltage, the capacitor voltage is going to be charged as 9 volt. It depends upon this source. If we reverse it, then that is going to be a less than 5. It will be a 5 minus 4, 1 volt. Okay, now it is adding with that, so it will be a 9 volt. Right. So after this, so after getting this 9 volt, now let's apply the output. So during next positive cycle, when we go for a next positive cycle, this charged capacitor has to be released, discharged through this output resistor. So we have output voltage here, and we have output expression for positive circuit, that is V out is equal to V in plus Vc. If you don't remember that, then apply KVL, you'll get it. So this is positive, this is negative, because it is a positive cycle now. So positive, negative. And the capacitor is charged like this. So plus Vin, we can write plus Vin plus Vc minus Vout equal to 0. Therefore, I can write it as Vout is equal to Vin plus Vc. I will write it here. Vout is equal to Vin plus Vc. Now you can write a condition for different input voltages. Vout, if Vin is 0. If Vin is 0, then 0 plus 9. Vout will be 9 volt. Okay, same way if Vin is maximum 5 volt. If it is 5 volt, then 9 plus 5, it is 14 volt. And if Vin is maximum minus 5, then minus 5 plus 9, it will be 4 volt. It's going to be a 4 volt. This is an output. Now let's plot it. Say once while plotting it, let's start with the negative portion here. Right. So it is starting here. Output we are getting at this next cycle here. So I will start with the next cycle only. So Vout is 9 if input is 0. Say somewhere here 9. So this is, say, let me take this as positive 9. This is positive 4. We got 4, 14 and 9. So this is positive 4 and this is positive 14. Okay. So at 0 we have 9 volt. Say at 0 I have 9 volt. Okay. When it is at maximum 5 positive cycle, we have 14. So it will be 14 at positive cycle and it will reduce. And when it is minus 5, it will be 4. So when it is minus 5 again, it will be 4 volt. So it will be 4 volt. So we get it like this. This will be a cycle we are going to get. So this picture, whatever we had here, is started from 0 and reached 5 and minus 5. Here is starting from 9, reached 14 and 4. So this is being shifted to the positive side. But it is not shifted from the 0. It is not touching 0. It is touching 4 here. Because we had a source. This is plus 4 we have. So it is positive side. Below 0, above 0, it is plus 4 has been added. Okay. So that is why it is shifted some more above the 0 level. That is how you can understand. Right. And finally you should cross check it like this. Here the peak to peak value is plus 5, minus 5. Peak to peak is 10. Same way here 14 and 4. Peak to peak remains same. It is 10. So that should not change. Now let me tell you the short trick how to get without these expressions. Okay. So I'll tell that point now. Very simple. Look into the input waveform. This is positive 5, minus 5. Okay. So and looking into the diode, you should understand that this is a positive clamper because positive terminal is connected to the ground. So it will shift towards the positive. First you should have this picture in your mind. It will be shifting like this. It will be shifting like this. And we know peak to peak what it should be 10. So if this is going to be 10, this is going to be 0. If this was not there, this source was not there, this is how it will be. But now we have a source and that is positive towards the anode. So towards this diode we have positive. So we should add plus 4. You just shift 4 more above. Okay. Just shift 4 voltage above this 0. So you can shift it like this. You just shift it 4 above, so we can draw it like this. If this is 0, 4 and we get it like this. So it should be 4 to 14. So in between we get it as 9. We got it the same. So this is how we can just by looking into this circuit we can get the output waveform. For example, if I change this as a, if I change this like this, if I change the directions, you can try for this. If you change this, see now apply the 4 volt same. You try for this by just looking into this. You can try it. We have positive, but we have a negative 4 volt here. We have negative 4 volt. First, without this, this is what the output. Now we have a minus terminal here, minus 4 volt. So it will be shifting towards down. So what happens for this circuit? We can say the output will be something like this. If it was just without this, then it is positive. This is the output. Now with this minus 4 volt, it will be shifted downwards. It will be shifted downwards. How much? Negative 4. So we can have minus 4 here and we get the output like this. We can get the output like this. Okay. So minus 4 to how much? The peak to peak value should be of a 10 volt. So minus 4 and this has to be plus 6. Okay. 0 to 6 and here 0 to minus 4. Total 10. So this is what the shifting will be. Right. So based on this circuit, you just need to shift it. I hope this is clear for you. If it is clear, share with your friends and also don't forget to subscribe to my channel. Thank you.